So in exercise 223, it says, for each of the structures below, draw the resonance structure that is indicated by the curved arrows, and be sure to include any formal charges. These red curved arrows are something that will be with us for the rest of organic chemistry, and for the rest of a long and rich life, where I'm sure organic chemistry will be very present. And so the curved arrows show the movement of electrons, not of atoms, of electrons. It's the bonds and the lone pairs that are going to be changing their place. You're not moving atoms around. So the first step in drawing the other resonance structure here is to retrace this molecule exactly as it is, copy it down, just without the curved arrows. The second thing you want to do is to draw the hydrogens in. This is going to help us to see the new formal charges that we have when the electrons move in the way that the curved arrows are describing. So we'll go one atom at a time here. This atom, this carbon here, the way it is right now, it has two bonds drawn explicitly, and so that means it needs two more, and those would be two invisible hydrogens. Any carbon that does not have a formal charge needs four bonds, and so if only two are drawn, then two are going to be invisible, and those invisible bonds are always only to hydrogens. This carbon here, there's no formal charge on that, so it needs four bonds total. It has 1, 2, and 3 already drawn, so it just needs one more to make 4. So we've got a hydrogen there. Last but not least, on the right, this carbon here. Now this one does have a formal charge. So that one may not have 4 bonds. We have to think about it. Carbon is in group 4a, so it's going to be 4 minus. There are no dots around that carbon. Carbon only has lone pairs when it has a negative charge. And now we don't exactly know how many bonds it needs, so I'm going to leave that blank. But what we do know is that the overall charge has to be positive 1. So really this is 4 minus what gives us positive 1. And it's 4 minus 3. 4 minus 3 gives us positive 1. So if carbon has a positive charge, it needs 3 bonds total, not 3 invisible hydrogens, it needs 3 total bonds. It already has 1 drawn in, so that means we need 2 and 3. So that carbon only has 2 hydrogens on it. And you can always double check. Find the formal charge of it with those hydrogens there. 4 minus 0 dots plus 1, 2, 3 lines, that's positive 1. That's the charge that they gave us. So you can tell that's the correct resonance, or that's the correct number of hydrogens there. Okay, now that we have the hydrogens drawn in, we can go back, look at the curved arrow, and move things. Now anywhere where there was the tail, anywhere where there's the tail of the curved arrow, those electrons are moving away from that place. And so you would erase the electrons there. Any place where the head of the curved arrow points, that's where the electrons are going, and so you form, or you move the electrons there. And so if the arrow points at a bond, then you form a bond. If it points at an atom, then you form a lone pair. And so that's how the electrons move here. All we have to do is go back through this atom and check the formal charge for each of these carbons. So this carbon here, it's 4 minus, we have 4 minus, we have 0 dots, no lone pairs around that. 1, 2, 3 bonds, so 3 lines. 4 minus 3 is positive 1. So that carbon on the left now has a positive 1 charge. How about this carbon in the middle? 4 minus, there are no dots on that. 1, 2, 3, and 4. 4 lines. 4 minus 4 is 0. That carbon has a 0 formal charge. How about the carbon on the right, this carbon here? 4 minus 0 dots. 1, 2, 3, 4 lines. 4 minus 4 is 0. The positive charge is no longer on that carbon. Now it is neutral. So once you have this structure, now that we have the formal charges all correct, we can get rid of the hydrogens. In the bond line structures, you're not supposed to have them anyway. And so that there would be your final answer for this. This is the other resonance structure that the curved arrows are trying to communicate to you in this. All right, let's try to apply that same procedure to B. So the first step here is just draw the same atoms exactly as they are. Draw the whole molecule exactly as it is. Lone pairs, negative charge. Just don't include the curved arrows. Next step, in order to figure out the correct formal charges later, it'll be useful to draw in the hydrogens before we move electrons around. So we know exactly how many bonds are around each of these atoms. So this carbon on the left has only 2 bonds drawn. And because it does not have a charge on it, it needs 4 bonds total. So this already has 2 bonds, form 2 more, and those are 2 invisible hydrogens. This next carbon here, that carbon has 3 bonds drawn to it. That means it needs 1 more in order to get 4, and you know it needs 4 because it doesn't have a charge on it. The carbon on the right. Now that carbon has a formal charge on it, and so it doesn't necessarily have 4 bonds. We have to think a little bit about the formal charge in order to figure out how many bonds it has. It's carbon, so it's 4. 4 minus how many dots? We see 2 dots. Plus, we're not really sure how many lines, so x. And the overall charge has to equal -1. So 4 minus 2, that's going to be 2. Oops. 2, and so then it's 4 minus each of these things. If you distribute this negative charge, it's 4 minus 2 minus x equals -1. So 4 minus each of those things. So 4 minus 2 is 2, minus x equals -1. And if you do the algebra here, add x to both sides, cancels on the left, you have 2 equals -1 plus x. You add 1 to both sides, and it cancels on the right, and so x equals 3. Okay, so we need 3 bonds. Now, in order to avoid doing all of that algebra again, you might just remember, if you have a carbon with a negative charge, it needs a total of 3 bonds. And so you can form those. It already has 1 bond drawn in. We therefore need 1 and only 2 more hydrogens. Now it has a total of 3 bonds. Okay. So, and actually, let's do this. So, okay. So, this is our molecule that we have right now with all the hydrogens drawn in. And you can always check that you wrote in the right number of hydrogens there, because it's 4 minus 2 dots plus 3 lines. That's 4 minus 5. It's -1. So -1 charge. So when a carbon has a negative charge, it needs 3 bonds around it. Okay, now that we have all the hydrogens drawn in, we can follow the curved arrows in order to see how electrons move. Now, any place where the tail of the curved arrow is the place where electrons are going to move away from, and so you erase electrons there. Any place where the head of a curved arrow points is where electrons are going, and so you add electrons there. Remember, if an arrow points at an atom, then you add a lone pair. So again, any place where the tail of an arrow is pointing, those electrons get erased. And anywhere where the head of an arrow is pointing, those electrons get added. And if it's pointing at a bond, and you form a bond. Okay, once you move the electrons, you have to go back and correct the formal charges. So first, let's deal with this, the formal charges on this carbon here. So that carbon is 4 minus 2 dots plus 3 lines, negative 1. So that has now a negative 1 charge. You might just put a negative. The carbon in the middle, 4 minus 1, 2, 3, 4 lines. So 4 minus 4 lines. 4 minus 0 dots and 4 lines. That's 0, so that has a 0 formal charge. And this carbon here at the far right, that carbon has, or that carbon would be 4 minus 0 dots and 1, 2, 3, 4 lines. So that should have a 0 charge, so that no longer has the negative charge that it had in the other structure. You can clean up these. I'm just going to clean this up so it looks a little neater. And the last thing you'd want to do is to erase those hydrogens, because in bond line structures, any hydrogens to carbon are implied. They're just implied. And so that there would be your other structure, the resonance structure that the curved arrows are trying to communicate. Okay, let's try C. First step is to draw the molecule exactly as it is. Okay, now here we want to draw in hydrogens, and really you only have to look at the hydrogens that are involved in the atoms around the curved arrows. So notice the curved arrows are dealing with these atoms here. They're not dealing with the atoms on the end. And so we'd only have to think about the hydrogens for those. Those are the places where the electrons are moving around, so those are the places where the formal charge could change. Now if you look at this carbon here, that's the only carbon in that region. So that carbon doesn't have a formal charge, so it needs 4 bonds. And lo and behold, 1, 2, 3, 4, it already has 4 bonds. So it has no hydrogens. Okay, now that we've taken account of the hydrogens that are relevant, we're going to look at those curved arrows. So first, anywhere where there's the tail of a curved arrow, the electrons are moving away from that, and so you'd erase those. Anywhere where there's the head of a curved arrow, electrons are going there, and so you're going to add electrons to that. Now, if the head of an arrow is pointing at an atom, then you add lone pairs. Okay, again, anywhere where there's the tail of a curved arrow, those electrons are moving away, and so you erase those. Anywhere where there is the head of an arrow, those electrons are arriving there, and so you add those in. And if the head of an arrow points at a bond, then you add a bond. Okay, now we just have to go through this, check the formal charges. Let's think about this oxygen. It's in group 6A, minus 6 dots are around it, plus 1 line is around it, so 6 minus 7 is negative 1. That has a negative 1 formal charge. Let's think about the carbon. We're going through each of these atoms that were relevant in the structure, that were involved in the movement of electrons. Carbon, group 4A, 0 dots around this. There's 1, 2, 3, 4 lines. So 4 minus 4 is 0. How about this oxygen? Oxygen's in group 6A, 6 minus 2 dots plus 1, 2, 3 lines. 6 minus 5 is positive 1. And so this oxygen at the bottom will have a positive 1 charge. So I'll erase these equations just to clean this up a little bit. And that there is your beautiful molecule. This is the structure that is trying to be, the molecule on the left, the curved arrows in the molecule on the left, are trying to communicate. All right, let's do D. So in this one, first step Just redraw the molecule exactly as it is. Just don't include the curved arrows. All right, next, let me circle the area where the formal charge could change, the area where electrons are moving. That's in that purple area there. Notice the electrons aren't going onto or off of the other areas on the side. So the formal charge wouldn't change there. Now we want to draw hydrogens on any carbons in this area, and so let's start by looking at this carbon here, right, that carbon. This carbon, it does not have a formal charge, so it should have 4 bonds, and lo and behold, it has 1, 2, 3, 4 bonds. So that carbon does not have any hydrogens. How about this other carbon? Oh, it has the lone pair with a negative charge. Now, if you remember, something you might want to remember is that if you have a lone pair with a negative charge on a carbon, it needs 3 bonds total. It already has 2 drawn, so you just need 1 more. You can always check. Carbon is in group 4A minus 2 dots plus 3 lines. 1, 2, 3. That's 4 minus 5, negative 1. And that gives you your negative 1 charge. Okay, so now that we have the hydrogens on the relevant atoms, let's move those electrons. Anywhere where the tail of an electron is, or a curved arrow is a place where electrons are moving away from, and so you erase those. Anywhere where the head of a curved arrow is pointing is a place where electrons are going, and so you add electrons there. If it's on an atom, then the electrons you draw are drawn as a lone pair. With the other one, anywhere the tail of a curved arrow is where electrons are moving away from, and so you erase those. Anywhere where the head of a curved arrow is pointing is a place where electrons are arriving, and so you add in electrons there. If the arrow is pointing at a bond, then you draw a bond. Okay, now we need to go through this, look at the relevant atoms, and calculate the formal charge on them. Let's start with the nitrogen. Nitrogen is in group 5A. 5 minus, we have 4 dots there, and 2 lines around that nitrogen, 1 and 2. So it's 5 minus 6, or negative 1. That nitrogen will have a negative 1. Okay, think about this carbon. Carbon is in group 4A. We have 0 dots around that, and if you count 1, 2, 3, 4, you have 4 lines. So that's a 0 charge on that carbon. Finally, on this carbon, group 4A, we have 0 dots around it. We have 1, 2, 3, and 4 lines. So the overall charge on that now is 0. So the negative 1 doesn't stay. Oops. And so that is our molecule. You just want to erase the hydrogen, because in bond line structures, hydrogens bonded to carbons should be invisible. And so this structure here is the structure that the curved arrows on the left are trying to communicate to you. We'll continue this problem in another video to avoid making the videos too long.